in the case of hydrogen atom, the potential energy of electron is the electric potential energy, which will be phi is equals to minus E squared over 4 pi epsilon OR. Because phi is the function of R, that is the radius, instead of x point y point c, so we could not to substitute phi directly into the Schradinger equation. To make synchronous Schradinger equation and the electric potential energy of electron, we have to transform the Cartesian coordinate x point y point c into the spherical polar coordinate r point theta point phi. The relationship of Cartesian coordinate x point y point c and spherical polar coordinate r point theta point phi could be described as follows. This is coordinate point P, x point y point c, or r point theta point phi. This is theta, the zenith angle, that is the angle formed by the radius vector and c-axis. Based on this description, we find that cos theta is equals to c over r. And this is phi, the azimuth angle, that is the angle formed by the radius vector in xy plane and x-axis. You can say the radius vector in xy plane as r prime. So based on this description, we find this angle is theta 2. So sin theta is equals to r prime over r. R prime over r equals to sin theta. So we find that sin phi is equals to y over r prime, or equals to y over r sin theta. And cos phi equals to x over r prime, or equals to x over r sin theta. So we find that x equals to r sin theta cos phi, y equals to r sin theta sin phi, and c equals to r cos theta. Okay? To abbreviate this lecture, we will write soon the Schradinger equation in the form of spherical coordinate system as follows. 1 over r squared d over the r of r squared d psi over the r plus 1 over r squared sin theta times d over the theta of sin theta d psi over the theta plus 1 over r squared sin squared theta times d over the theta times d squared psi over dv squared plus 2m over h bar squared times e minus phi times psi equals to 0. You can learn the concept of Laplacian or Del operator to see the origin of this equation. Now if we multiply this equation by r squared sin squared theta and then substitute phi equals to minus e squared over 4 pi epsilon of r into the equation, we obtain sin squared theta times d over the r of r squared d psi over the r plus sin theta times d over the theta of sin theta d psi over the theta plus d squared psi over dv squared plus 2m r squared sin squared theta over h bar squared times E square over 4 pi epsilon OR plus E times psi is equals to 0. This is Schradinger equation of hydrogen atom applicable in the real space. We see that Schradinger equation of hydrogen atom contains the variables of R, theta, and phi. We can separate these three variables to become the independent variables one another, because psi is the multiplication of radial wave function, Z wave function, and azimuth wave function. Thus we write psi equals to psi r times psi theta times psi phi, where psi r is the radial wave function. That is the wave function describe the radial position. Psi theta is the Z wave function, that is the wave function describe the Z position, and psi phi is the azimuth wave function, that is the wave function describe the azimuth position. And when psi is changed by the change of one variable, the other variables is remain constant. Thus we write d psi over the r is equals to psi theta times psi phi times d psi r over the r. D psi over d theta is equal to psi r times psi phi times d psi theta over d theta, and d psi over d phi is equals to psi r times psi theta times d psi phi over d phi. If we substitute these four equations into the Schradinger equation of hydrogen atom, we obtain psi theta times psi phi times sine square theta and d over d r of r square d psi r over d r plus psi r times psi phi times sine theta and d over d theta of sine theta d psi theta over d theta plus psi r times psi theta and d square psi phi over d phi square plus 2mr square sine square theta over h bar square times d square over 4 pi epsilon or plus E times psi r times psi theta times psi phi is equals to 0. Okay? If we divide this equation by psi r times psi theta times psi phi, we obtain sine square theta over psi r times d over the r, or r square d psi r over the r, plus sine theta over psi theta and d over the theta of sine theta d psi theta over the theta, plus 1 over psi phi and d square psi phi over d phi square, plus 2mr square sine square theta over e square square times e square over 4 pi epsilon o r plus e is equals to 0. Okay, we see that all parts in this equation contains the factor of z position sine theta, except the azimuth part. So we can separate the azimuth part from the other parts, and we write sine square theta over psi r and d over the r, r square d psi r over the r, plus sine theta over psi theta and d over the theta sine theta d psi theta over the theta, plus 2mr square sine square theta over s bar square times e square over 4 pi epsilon or plus e is equals to minus 1 over psi phi and d square psi phi over dv square. We see that the left side and the right side of this equation contains the different variables. So this equation is just right if the left side and the right side is the same constant. For simplification, we can say that constant as ml square for a reason we will understand later. Thus we write minus 1 over psi phi times d square psi phi over dv square is equals to ml square. And sine square theta over psi r times d over dr r square d psi r over dr plus sine theta over psi theta times d over d theta of sin theta d psi theta over d theta plus 2mr square sine square theta over s bar square like e square over 4 pi epsilon or r plus e is equals to ml square. Thus, after the separation of the azimuth part from the other part, we have two equations which have the same value, that is the constant of ml square. From the azimuth part, we find that d square psi phi over dv square plus ml square times psi phi equals to 0. Solution of this equation is psi phi equals to a times e to I ml phi. Because d square psi phi over dv square is equals to I square times ml square times psi phi, or equals to minus ml square times psi phi. So minus 1 over psi phi times d square psi phi over dv square is equals to ml square. That's why we take ml square as the constant for the azimuth part and the other part we have separated. And then if we divide this equation by sine square theta and then separate the radial part and the angular part, we find 1 over psi r and d over the r square d psi r over the r plus 2m r square over s bar square times e square over 4 pi epsilon of r plus e is equals to ml square over sine square theta minus 1 over psi theta sin theta times d over the theta of sin theta d psi theta over the theta. The left side and the right side of this equation contains the different variables. So this equation is just right if the left side and the right side is the same constant. For simplification, we can say that constant as L times L plus 1 for a reason we will understand later. Thus we write ml square over sine square theta minus 1 over psi theta sin theta and d over the theta of sin theta d psi theta over the theta is equals to L times L plus 1 and 1 over psi r and d over the r squared psi r over the r plus 2m r square over h bar square times e square over 4 pi epsilon of r plus e is equals to L times L plus 1. Okay? If we multiply this equation by psi theta, we find 1 over sine theta times d over d theta of sine theta d sine theta over d theta plus L times L plus 1 minus ml square over sine square theta times sine theta is equals to 0. And then if we divide this equation by r squared and then multiply it by psi r, we obtain 1 over r squared times d over the r times r squared d psi r over the r plus 2m over h bar squared times e squared over 4 pi epsilon of r plus e minus L times L plus 1 over r squared times psi r equals to 0. Thus, after the separation of variable of r, theta, and phi in the Schradinger equation of hydrogen atom applicable in the real space, we obtain three differential equations as follows. Equation 1, 1 over r squared times d over the r of r squared d psi r over the r plus 2m over h bar squared and e squared over 4 pi epsilon of r plus e minus L times L plus 1 over r squared times psi r is equals to 0. This is the equation of radial position in the real space. And equation 2, 1 over sine theta times d over d theta of sine theta d psi theta over d theta plus L times L plus 1 minus ml squared over sine square theta times psi theta is equals to 0. This is the equation of said position in the real space. And equation 3, d square psi phi over d phi square plus ml square times psi phi is equals to 0. This is the equation of azimuth position in the real space. Because Schradinger equation in the real space and the injury space take the same form, because the factor distinguish the differential of psi and psi omega is just the injury quantity of I. So Schradinger equation of hydrogen atom applicable in the injury space could be written as sine square theta times d over the r of r squared d psi omega over the r plus sine theta times d over the theta of sine theta d psi omega over the theta plus d square psi omega over d phi square plus 2m r square sine square theta over h bar square times e square over 4 pi epsilon of r plus e times psi omega is equals to 0. This is Schradinger equation of hydrogen atom applicable in the injury space. As well as in the case of Schradinger equation applicable in the real space, in the Schradinger equation of hydrogen atom applicable in real space, we can separate the variables of r, theta, and phi to become the independent variables one another, because psi omega is the multiplication of the radial wave function, set wave function, and azimuth wave function applicable in the injury space. Thus we write psi omega is equals to psi omega r times psi omega theta times psi omega phi. And when psi omega is changed by the change of one variable, the other variable is remain constant, so we write d psi omega of the r is equals to psi omega theta times psi omega phi times d psi omega r over the r, and d psi omega over the theta is equals to psi omega r times psi omega phi times d psi omega theta over the theta, and d psi omega over the phi is equals to psi omega r times psi omega theta times d psi omega phi over the phi. So, after the separation of variables of r, theta, and phi in the Schradinger equation of hydrogen atom applicable in the space, we obtain three differential equations as follows. Equation 4, 1 over r squared times d over the r of r squared d psi omega r over the r plus 2m over h bar squared times e squared over 4 pi epsilon r plus e minus ls times ls plus 1 over r squared times psi omega r is equals to 0. This is equation of radial position in the injury space. Equation 5, 1 over sine theta times d over the theta of sine theta d psi omega theta over the theta plus ls times ls plus 1 minus mls square over sine square theta times psi omega theta is equals to 0. This is the equation of same position in the imaginary space. And equation 6, d square psi omega phi over d phi square plus m ls square times psi omega phi is equals to 0. This is the equation of azimuth position in the injury space. Here, MLS and LS is the magnetic quantum number and the orbital quantum number applicable in the imaginary space.